We have previewed our text for overall noticings, and we have visualized to create mental pictures as we read. And with our last reading today, we're going to pull everything together and practice the skill of inferring. When readers infer, they connect what they already know or their background knowledge to information presented in the text to make an educated guess about what the text is saying or to extend the information in the text to similar situations. The skill of inferring helps me make reasonable and logical conclusions using information that is not necessarily explicitly stated or actually written in the text. Today, I will be reading the volcanoes section of our article to model how I make inferences. Please follow along as I read. As a tectonic plate slides into the mantle, the hotter layer beneath Earth's crust, the heating releases fluids trapped in the plate. These fluids, such as water and carbon dioxide, rise into the upper plate and can partially melt the crust, forming magma. And magma often means volcanoes. Looking at the Pacific Ring of Fire reveals the link between subduction zones and volcanoes. Inland of each subduction zone is a chain of spouting volcanoes called a volcanic arc, such as Alaska's Aleutian Islands. The Toba volcanic eruption in Indonesia, the largest volcanic eruption in the past 25 million years, was from a subduction zone volcano. This section about the Aleutian Island chain being formed by volcanoes in a subduction zone is one I can draw some additional conclusions about based on my background knowledge and information in the text. Although the text does talk about how crust melts at a subduction zone, forming magma, it does not explicitly state that the boundary between the plates at a subduction zone also makes it easier for this magma to escape or seep up or bubble to the surface, thus forming volcanoes, which turn into island chains like the Aleutian Islands. But I know that the area where the two plates meet is accompanied by this fissure or junction point, so I can infer that this is where most of the lava is likely to seep up from and form volcanoes. My own experience with having liquids seep out of containers that have a small crack has shown me that liquids will leak out where existing cracks already are, and it would make sense that there would be those along plate boundaries. Another piece of background knowledge I have relates to the Hawaiian Islands that I've traveled to, and I know were also formed by volcanoes. I am wondering if the Hawaiian Islands are also on a subduction zone or plate boundary, but I don't think they are. A quick Google search revealed this reputable site that confirmed my gut instinct that the Hawaiian Islands are not near a plate boundary. So I can infer from this text that most volcanic islands do occur along plate boundaries, but not all of them do. But I'm inferring that most of them do. I came to this conclusion using my background knowledge and the text plus a quick Google check. Now, this is not meant to turn into a research project by any means, but you are welcome to use the tools at hand to help you confirm or collect some quick information if you need them for your inferences. You will now complete your third reading of the text. You may read silently or you may complete a paired reading with your partner. When you've finished reading the text, discuss what inferences you made. What reasonable or logical conclusions can you make based on the information in the text and your own background knowledge? You have two options for sharing these inferences, but both involve annotating the text with comments. And let me show you both. If you click on the next page in Schoology, you will find our synthesis activity. And on this page, you'll see two options for annotating the text. Just simply pick one. If you choose the Google Doc link, you will arrive at a Google document where you will have the ability to leave your inferences as comments. Go to the relevant section of the text, highlight it, choose Insert, Comment, and include your inference. If you want to use the Crocodoc link instead, simply go to the provided link. The first time you use Crocodoc, you may see these messages. You may get a message that says, "Welcome to Crocodoc. Thanks, let me in." You'll enter your name as a collaborator at the top of the page, and then you'll have these commenting tools. Once you arrive at the Crocodoc document, it will look like this. Again, simply go to the relevant area of the text where you want to leave your inference. Use this comment tool that is just over here on the corner of the screen. Choose Text Comment, and leave your inference. Both Google and Crocodoc will autosave your comments, so you don't need to worry about clicking save. If you have any questions, please raise your hand. If not, go ahead and continue with your inference reading of what is a subduction zone.